All right, so the last section in the chapter is 3.6, is what we're going to talk about today, and it's proof theorems about perpendicular lines. So it takes a little bit about what we talked about with perpendicular lines, and then the proof part, and kind of puts it together. So there's some new postulates and theorems, and then we're going to learn how to apply them. So theorem 3.8, and again, we've talked about it before, but the number itself is not important, okay? It just means that this is the 8th theorem that's mentioned in chapter 3. And in any other book, this theorem still applies, but maybe it's in a different order, so you don't want to get attached to the number. What it says is what's important, which is if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So there's two things happening here. There's a line, obviously, that's split by two angles, so it has to be a linear pair to begin with. And then you would have to know that one is congruent to two. If they're congruent, think about it logically. What's true about two angles that are a linear pair? They're 180. So if they're the same, they have to be 90. And if they're 90, what's true about those lines? They're perpendicular. Okay, so all of this just puts it all together into one. So if you are to use this as a reason on a proof, it's if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular.
So on the proof, there's no name or
Nope. There's no name. You have to write it out. You can shorthand it a little bit, but you do have to write it out. Okay, theorem 3.9. Again, same thing. Don't pay attention to the number as much as what it says. If two lines are perpendicular, then they intersect to form 4 right angles. So this would be almost your given part if, God bless you, A is perpendicular to B, then you can say any of those 4 angles are right angles. So I could say angle 1, angle 2, angle 3, angle 4, or a combination of them, doesn't matter which ones you're using, are right angles, and this is your reason. If two lines are perpendicular, they intersect to form 4 right angles. All right, 3.10. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So let's say that you got a proof, right? And your given was that these two lines are perpendicular, right? You could take this drawing and you could say, okay, if these are perpendicular, then this is then that would be given, right? Then this is a right angle, and that's the definition of perpendicular. You could do it that way, right? So I could say angle ABC equals 90 degrees, and that's the definition of a right angle. Well, first I'd have to say AB is perpendicular to BC, that's given. And then I would have to say, not of a right angle, sorry. And then I would have to say what I just wrote, which is definition of perpendicular.
And that'll be it?
Nope.
Oh, no.
Then I'm saying if you didn't use this theorem, right? Then I could say that angle 1 plus angle 2 equals angle ABC. What's that?
The angle addition postulate.
Good. Angle addition postulate, right? When we say that sum of the two parts is the whole, right? Then I could say angle 1 plus angle 2 equals 90 degrees. What's that? Substitution. And then I could say angle 1 and angle 2 are complementary. Perfect. Definition of complementary. So I could break it down, that whole thing that took 1, 2, 3, 4, 5 steps. It is not wrong. It's right. Or now you've got a shortcut. And the shortcut says this. If these are perpendicular, then 1 and 2 are complementary. And the reason is this theorem, which says if two sides of the adjacent acute angles are perpendicular, then the angles are complementary. So both of those would be completely right. Okay, some people get competitive and like to do it in less steps than others. I don't care. Okay, as long as it's the right steps, you would get it right. Questions? Okay. 3:11 says if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So we already know this for parallel. That was the parallel transversal, the transitive property of parallel lines. This is now perpendicular. So in this diagram, which one is your transversal? J. So if J is perpendicular to H, right, and H and K are parallel, then J is perpendicular to K. So you need two givens here. You'd need to know, first of all, you'd have to have a diagram that has a transversal. But you'd have to know that the two lines are parallel, and then you'd have to know that that transversal is perpendicular to one of those two. So I could have also said if H is parallel to K and J is perpendicular to K, then I can get J is perpendicular to H. So you could reverse that order. But there's two givens here, parallel and it's perpendicular to one. So it's almost like the transitive property of parallel, but it's not. It doesn't have a name. Questions on that one? All right, and again, think long way around this, right? So if I knew that this was true, if H is parallel to K and J is perpendicular to H, and that's given, and I didn't remember this theorem, how else could I prove that those second pair are perpendicular? I could use corresponding angles, right? So I could say let's say these work, 1 and 2, make my life easier. Angle 1 equals angle 2 because of the corresponding angles. What is it? Postulate, good. And then I could say angle 1 equals 90 degrees. Definition of perpendicular. And then I could say angle 2 equals 90 degrees. They didn't mention the word right angles. So you only want to, like if you're going from right angle to 90 or 90 to right angle, do you want to use definition of right angles? What they did give you is perpendicular. Substitution, good. And then if that is 90 degrees, then what? Then it's perpendicular. H is perpendicular, not H, sorry. J is perpendicular to K. And what's that? Good. Again, you could go through those 5 steps, or you could use the given and the proof using this theorem. So you could go through those 5 steps, it's still right, or you could go from here. If this is true, that's your given, then this is true, and your reason is if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other. All right, 3:12. This one has a name. Lines perpendicular to a transversal theorem. So you can actually use that. It's not that much shorter than the whole thing, though. This one says, in a plane, if two lines are perpendicular to the same line, then they're parallel to each other. No, so the last one said, if one of the parallel lines was perpendicular to the transversal, then the other one is. So that one you're proving that it's perpendicular. This is saying if they're both perpendicular, then they're parallel. It's kind of like the reverse, yeah. So how else could you have proved this without using this long one? Corresponding angles. Okay, I could have said those two angles are congruent. If those two angles are congruent, then the lines are parallel. What's that, though? So if I'm proving the lines are parallel, what's my reason? The converse. Good. Yep. Does that make sense? Remember, if we're proving things about the angles, it's the original ones. If we're proving the lines are parallel, it's the converse. Questions so far? So you can remember that big long name, or you can write it out. It doesn't matter to me. As long as you explain it, it's fine.
There's no abbreviation for
Okay, distance. So the distance from a point to a line is the length of the perpendicular segment from the point to the line. So if I gave you a point, like this one, and then the line, and the blue wasn't there, let's say, and I asked you to give me the distance from that point to the line, you can't draw like segments all over the place and say I can measure any one of those and give the distance, right? The true distance comes from the one segment that is the perpendicular segment, which is this one. That is true distance. So true distance is perpendicular. Then the second thing says between two parallel lines, the distance between two parallel lines is the length of any perpendicular segment joining the lines. So I could pick any perpendicular line along this way, and that would represent the distance because the parallel lines are always equidistant from each other, right? Lewis?
Is that because it's like the shortest path?
Yep. Mm-hmm.
Is this like a theorem or something?
No, this would be the definition of the distance between a point and a line, or the definition of the distance between two parallel lines. Yeah.
So say for the first one, the line is tilted, it's at like an angle, and then you have the point.
So you have the point here and a line like this.
Yeah.
So you would still figure out perpendicular.
Oh, okay.
That would be your distance.
Okay.
So you'd always want it to form a right angle. Good question.
Why is it two?
Sorry?
Why is it like two?
Because this is two lines, right? So if two lines that are parallel, they're always going to be the same distance apart. So I could pick any point on here, and then the distance is going to be the perpendicular segment. I mean, that's not perfectly parallel, but any of those which should be the same because they're always going to be the same distance apart. So you're always looking for that right angle. That's what's going to show you the true distance. So if I gave you like this, and this said like 5, and this said 4, and this said 3, and I asked you what's the distance between the point and the line, you're going to tell me it's what? 3. Does that make sense? Okay. All right, so example 1 says, in the figure, angle 1 and angle 2 are congruent. What can you conclude about the measure of angle 2?
Since it's perpendicular, all four angles. Right?
Yep, so what would it be? What would be the measure of angle 2?
Oh, 90.
Yep. Okay, and that is because two angles that form a linear pair, right, are congruent. If that's the case, then the angles are 90 degrees. Make sense?
Would you also
So it would be if two congruent angles form a linear pair. Then they are right angles.
well, could you also like turn the figure and then you could be supplementary angles?
Yeah, it's just you would go even more specific because technically 1 and 2 are supplementary, but 2, you could say 2 is the supplement to 1, but it's asking you to focus in on 2, so the better answer is that it's 90.
Okay.
Because yes, they are supplementary, but the fact that they are congruent is what makes them 90. All right, example 2, prove that if the measure of angle 1 and the measure of angle 2 are complementary, then BA is perpendicular to BC. See if you could do this. All right, who thinks they have the second step? Gio.
Measure angle 1 plus the measure of angle 2 equal 90 degrees.
How many of you had that step? Okay, what's the reason?
Definition of complement.
Go ahead. What's your next step?
But angle ABC equals measure of angle 1 plus measure of angle 2, which is addition. Angle function, or angle addition function.
Angle addition postulate. Good. Then?
Then I put angle ABC equals 90 degrees, substitution.
Then?
Then I put BA is perpendicular to BC, so it's definition of
Nicely done, sir. Who else was on that track or had it pretty similar? Oh boy, folks, a couple hands go up. All right. Questions if you didn't, like if you think yours might actually work a different way. You could have put 3 in front of 2. The order there could have been reversed, right? Because you could say that just from the get-go. You can even put 3 before the given because you just need the diagram to get that. But you do have to state that like both 2 and 3 before you can get to 4. Questions? So I would say as far as proof on your test goes, this is kind of on level. It's not going to be much easier than this. It's not going to be much harder than this, okay? I'm not saying it's going to be this, but if you're, easy, middle, hard, I would say this is pretty close.
Test is Tuesday.
Test is Tuesday, yep. But remember, I don't see you Monday.
What was the last proof?
All right, determine which other lines, if any, must be perpendicular. So according to this diagram, there are only 2 pairs of lines that are perpendicular, right? Which ones? C and B. Is it possible to prove that C is perpendicular to anything else?
Yes.
Why? Well, which one, first of all?
A.
C perpendicular to A, but why? And don't tell me because it looks like it is, because that doesn't work.
Correspond.
Okay, so if I went through the proof, first of all, I would have numbers and stuff on the angles there, right? But I could say, given that this is perpendicular, that's one given, then I can say that this angle is congruent to this angle, right? That would be definition of congruent if I had to actually write it out. And then you could say that line A and line B are parallel, and that's the corresponding angles postulate, right? Wait, no, postulate. Converse, good, because you're proving the lines are parallel.
Do you transitives to show that the angle C's line C is equal to angle?
No, because you're not saying they're both parallel to the same line. You're saying if these are parallel, then these are perpendicular, and that could also be corresponding, or it could be the theorem that said if the transversal is perpendicular to one of 2 parallel lines, then it's perpendicular to the other. So that was a whole lot of explaining. But A is parallel to B because the corresponding angles postulate converse. Then A is perpendicular to C because if one of 2 parallel lines is perpendicular to a transversal.
Wait, the second part, if we put if A is parallel to B and C is perpendicular to B, then C is perpendicular to A, is that fine?
Yeah, but if it says Y, you need the corresponding angles postulate converse to get that part. Perfect. And then you'd need if one of 2 parallel lines is perpendicular to transversal, then the second. Something like that. Okay.
You have to put like both of them. You have to put the corresponding angles postulate converse and
Yeah, because the corresponding angle postulate gets us that they're parallel, right? But then the second theorem gets us that if these are parallel, then they're right angles, or then they're perpendicular. So this only connects this part of my graph.
okay, so because the corresponding angles converse like proves that they're parallel.
Correct. And then you need that if it's perpendicular to one, then it's perpendicular to the other to get to the other ones.
Okay.
Yeah.
Can you just do consecutive interior for the right angle?
You could do, so if you're going to do consecutive interior, you would have to do, like, let's say that this is angle 1 and this is 2, okay? I would have to say angle 1 and angle 2 are supplementary, same side interior, right? Original, not converse. Then I'd have to say that if they're supplementary, that means they equal 180. Then if 1 is 90, so angle 2 plus 90 equals 180, substitution. Then angle 2 equals 90, subtraction. Then it's perpendicular, definition of perpendicular. So yes, but that's a lot of steps in between. Does that make sense? Yeah? Okay.
Could you like do corresponding with the right angle?
So that would be consecutive interior. That's what he's asking about. It wouldn't be corresponding. If you were going to link these two together using the parallel lines, then it would be same side interior, consecutive interior, and those are supplementary. So you'd literally have to say angle 1 and angle 2 are supplementary. And that's the consecutive interior angle theorem, right? Then I could say 1 plus 2 equals 180. That's definition of supplementary. Then I could say angle 1 equals 90, right? That's given, right? Oh no, that's perpendicular. So that's definition of perpendicular. Then I can say 90 plus angle 2 equals 180. And that's substitution. Then I can say angle 2 equals 90. And that's subtraction. And then I can say, what are those lines again? A is perpendicular to C, definition of perpendicular. So that is totally right. It's just a lot more steps. Tante.
For the fourth step, can you put the angle 2 is equal to 90 as well? Or you have to put the 90 plus angle 2 equal to 90?
Because you got to get that it's 90. It's not 90 yet. You just know that they add up to 180. Then I know one of them is 90, which means if I subtract that off, then the other one's 90. But you got to show those steps. So remember, the shorter way is to prove that they're parallel using this stuff, corresponding angles postulate converse. Then if one is parallel to the other, if one of two parallel lines is perpendicular to the transversal, then the other one is. So you can kind of do it in those, like with the given 3 steps.
Camera is a weird thing that it shows what I did.
All right, example 4, last one, says what is the distance between the 2 parallel sides of this tabletop? All right, so think about how I would find the distance between the 2 parallel sides. So first of all, which ones are the parallel sides?
2 sides.
This one and this one, right? How would I find the distance between them?
You can't just assume that they're
Condition
parallel.
it, they're all.
So if you wanted to prove they were parallel, how would you prove they're parallel?
Find the slope of both.
Oh, yes, right.
Very good. Find the slope of both and compare them. So I'm going to find the slope using these 2 points, and then I'm going to find the slope using these 2 points. So the slope of the first one is 6 minus 3 over 4 minus 0, which is 3 over 4. And then the slope of the second one,
2 plus 1.
2 minus negative 1 plus 1 over 7 minus 3, 3/4. Okay, so now we know which ones are parallel, because these definitely look like they're more parallel than the other ones, but they could actually get pretty close and then you wouldn't know the difference. All right, so now I know that these are the parallel ones, right? So now I need to find what?
Where they're perpendicular.
Where are they perpendicular? So let's think about what it might look like. Might look like it's perpendicular there. Might look like it's perpendicular there. How do I know which of those are going to be perpendicular? The slope of that compared to my original green ones, right? So which one do you want to guess first?
4 and 6.
4, 6, and 7, 2. So now we're going slope 3, right? Which is 2 minus 6 and 7 minus 4, which is negative 4 over 3. All right, so we found that this segment here is perpendicular to both of them, yes?
Mm-hmm.
So if I wanted to find the length of that segment, how do I do that? Go way back to last chapter.
What did you say?
Actually, chapter 1. How do I find the distance between,
Isn't it
or the length of this?
the square root?
Yep, distance formula. Okay, which is really good SAT prep before we get there. So D equals square root of x2 minus x1 squared plus y2 minus y1 squared. So much fun, right?
And what was like that other equation in that chapter?
The midpoint. x1 plus x2 divided by 2, y1 plus y2 divided by 2.
We need to know that for me.
We just did it yesterday.
Yeah.
So I got 4, 6, and 7, 2, right? x1, y1, x2, y2. So I get 7 minus 4 squared plus 2 minus 6 squared.
Is the next chapter more theorem?
Yes.
I want to do
Okay, distance between those. Now listen carefully to me. Listen, listen, listen. If that was not a perfect square root, what are you going to do?
Getting it like a 2 square root.
Use your factor tree if you can. You're going to leave it. It's called exact because you're not going to round it. So I think on the review it even says like to round it. Don't round it. Leave it exact because on your test you're going to do the same thing. You would leave it exact. So if it's not a whole number, if it was like square root 20, right? Then remember you've got to use your little factor tree. So this is 2 and 10, 2 and 5. And the pair of 2s goes to the outside. The single one stays underneath. Okay? So we did do that, back in chapter 1.
Like that, or you want it
I want it like that. Yep.
What if it's an odd number, like the pair?
Then it would stay. So if it was like square root 15 and you get a 3 and a 5 and nothing repeats, then it stays square root 15.
And what if you get like an unextended, like 4, like there's like 3, you can simplify it 3 times.
So let's say it's 40, right? You get 2 and 20, 2 and 10, 2 and 5. This pair comes to the outside. These don't have a match. They stay underneath and get multiplied together.
Oh.
So if you can take out more than 1, you multiply it on the outside. If you can leave under more than 1, then you multiply on the inside. Does that make sense?
Yeah.
Okay.
Is there gonna be a question like this on the test?
There's a question in which you have to find the distance between 2 segments. Yep.
Yes.
Questions? All right, I'm going to publish your